Hey there, CJ Math students, and welcome to today's lesson for Tuesday in math, and it's our second day on probability. So today I'm going to kind of really give you a definition of it. It's basically it's a science used in everyday life to predict the chance of something happening. Right? When you think probability, you should think, oh, what's the chance that that desired thing is about to happen, or that undesired thing is about to happen? Probability is always measured on a scale of 0 to 1. And yesterday, we started talking about this in the Zoom meeting as well. 0 is something that's impossible. So, like, what is the probability if I have a bag of nothing but green marbles that I pick a yellow marble? That's impossible because there's no yellow marbles in there. What is the probability if I have a green bag of marbles, like with 50 green marbles and one yellow marble? That's probably a really poor chance. It's close to impossible, but it's still possible. If I had a bag of 25 green marbles and 25 yellow marbles, then it'd be an even chance. If I had a bag of 25 green marbles but like 50 yellow marbles, then you'd have a pretty good chance of grabbing a yellow marble. And then if I had nothing but a bag of yellow marbles, then the probability of grabbing a yellow marble would be certain, right? So the probability is always written as a fraction, decimal, or percent. We've worked on that before. And it often has the annotation of P and then parentheses what you desire. So this is saying, what is the probability of rolling a 4 with this dice? Well, there's only one 4 on the dice, and there are 6 different numbers. So that's why it's 1 out of 6. So the probability of rolling a 3 would be also 1 out of 6. The probability of rolling an even number, think about it, there's 2, 4, 6, so there's 3 even numbers. So the probability of rolling an even number would be 3 out of 6. When you're thinking about something like a coin, right? The probability of flipping one coin and getting a heads, well, there's only a head and a tail, so there's only 2 options, and there's only one head, so 1 out of 2, right? We will start talking about tree diagrams eventually. This is kind of compound events. So it's what's the probability of tossing a heads and getting heads again and heads again and heads again and heads again. In order to figure out what's the probability of getting heads twice in a row, you take the probability of the first event, which is 1/2, and you multiply it by the probability of the second event, which is 1/2. And you'll notice that these probabilities do not change because they are independent events. And what is an independent event? It is when the outcome of one event does not affect the outcome of another. The events are independent. So if I flip a coin and I get heads, and then I say, okay, I bet you $5 that I'm going to get heads the next time. Well, you had a 1 in 2 shot the first time. That just because I said I'm betting you $5 the second time, it doesn't matter, right? It's still a 1 in 2 shot. The first time did not affect the second time. If I flipped heads a coin and got heads 15 times in a row, and I said, I bet you I get heads again, you're like, well, you've gotten it 15 times in a row. It's got to be tails now. No, the probability is still 1 out of 2. It's a very, very unlikely chance that you would get heads 15 or 16 times in a row because, by probability standard, eventually you would probably get a tails in there. But no matter what, they are independent events. So for your work today, you should have already completed this bubble for ST Math yesterday. And for today, I want you to complete these 2 bubbles. So let's take a look at what they look like. If you have already completed these 2 bubbles, or I guess these 3 bubbles now, awesome, good for you. You just need to finish this Edpuzzle video and then email me the definition of probability and the code word for today, as I say in the video. So let's take a look at one of these levels. So in this first bubble, it's just about the probability of selecting B. Remember yesterday, we had likely and unlikely and improbable and probable. So something that is probably not going to happen, B, because it's a smaller piece of the pie, is improbable. So improbable matches up with unlikely, and probable matches up with likely. All right. As you move along, the questions actually might start to offer you more than 1 or 2 options. So what's the probability of selecting B? As you see, you can go along the continuum of impossible, improbable, certain, or probable. This one is definitely certain because there's nothing but B there. If there was one little sliver of something else, then it would be probable, all right? Here, what's the likelihood of selecting G? As you can see, G is the most shaded. That doesn't mean it's certain that it's going to land on G, but it's probably likely. So you'll notice you'll have 4 steps to complete in this bubble. That would be that second bubble that you're done. And then you have 4 steps to complete in this bubble right here. This bubble is somewhat similar, except instead of a spinner, we have a jar, and you're going to put the continuum, your answer on this line. So what's the probability of selecting P from the jar? Well, there's only one P purple marble, so it's absolutely certain. I can't grab anything else, so it's definitely 1 out of 1, hence why it ends up on certain. Again, what's the probability this time of selecting P from the jar? But this time you see that there's only a yellow marble in there, so it is impossible to select a purple marble. They might try to confuse you and say, oh, look, there's 2 orange marbles, so maybe the probability is selecting 1 out of 2. Wait, no, we're still only trying to select 1 orange marble, and if there are just 2 orange marbles, then no doubt when I pull out one, it's definitely going to be orange, whether I pull out that first one or that second one. So the probability there's 2 orange marbles out of a total of 2, it's still a certain. 2 out of 2 becomes 1. All right? As you get to some of the harder problems, you'll see what's the probability of selecting Y from the jar. You're probably going to want a paper and pencil to actually write down these numbers. So first, you're going to want to count up all the marbles. So 1, 2, 3, 4, 5, 6. So that's your denominator. However many marbles there are in the bucket, that's your denominator. And then you're looking at what you want. You want Y. So 1, 2, 3. So 3 is your numerator. So 3 over 6. You'll notice you don't see 3 over 6. You'll have to simplify it. If you want to use a paper and pencil or your calculator, 3 over 6, hit enter. You'll know that 3 over 6 is 1/2. So it will require you to simplify some fractions here in order for you to get the right answer. And read the words carefully, because sometimes they might try and trip you up with what they're saying. So what's the probability of selecting B here? You'll notice again 1, 2, 3, 4, 5, 6. There's 6 total, so that's my denominator. 1, 2, 3, 4, 5 blues, so 5, 6. So those are what you're trying to do in that last bubble. Just for Edpuzzle's sake, let's see what's the probability of selecting P from this jar here. You'll notice again there's 2, 4, 6, 8 total marbles, so 8 is your denominator, and you want P. Give me the answer in Edpuzzle. So you'll know you're done if this bubble, and this bubble are all green, and Gigi is on basically this bubble. So you should be able to take a picture of this screen right here with these 3 bubbles in all green. Email me that picture with a definition of what probability is and today's code word. That's it. Have a good one.